Today we're going to work with inverse trig functions. So I want you to remember a couple things. So far we've worked at finding values of trig functions at different angles and figuring out what those values are. But sometimes we need to be able to figure out what angle would give a specific sine, cosine, or tangent value. In order to do this, we need to have inverse functions. So I want you to remember that inverse functions need to be one-to-one. And you might be thinking, well, sine and cosine have this kind of thing, and there's no way that could be one-to-one, because if I put a little line here, it intersects more than once. That's what it means to be one-to-one. So in order to do that, since they're not one-to-one, we're going to have to restrict the domains. Now we're going to choose the domains here to include the angle of 0. So sine is going to be limited between negative pi over 2 and positive pi over 2, because that gives us a 0 here in the middle. So that's a piece of the sine graph. Cosine is going to be limited from 0 up to pi, because that gives us the piece that we have here. It includes 0. I'm now 1-to-1. And then tangent has to be restricted between negative pi over 2 and positive pi over 2 to keep it and make it 1-to-1, whereas we got that 0 angle in the middle as well. So when we look at these, we need to look at a couple things. Alright, so for angles in that interval for sine between negative pi over 2 and positive pi over 2, if the sine of an angle is equal to a, then the inverse sine of a is equal to the angle theta. Alright, so the inverse sine function has a domain from -1 to +1, and then the range is going to be from negative pi over 2 up to positive pi over 2. So that means our interval that we start with, that we restrict our domain to, ends up being the range of our inverse sine function. Another thing you might see every now and then, instead of the little sign with the -1, and we say sine inverse, would be arcsine. Again, it's the same thing, just another way of writing it. In some books, some problems will have it written the other way. Ours, we'll just use the inverse notation with a little -1. So for angles between 0 and pi, we can do the same thing with cosine and define an inverse cosine function. And if you look at the graph here, we start up here when x is -1. We have a value of pi, and when I go down to over to 1, I get back to 0. Which again, it looks a lot like the cosine graph just turned. And then inverse tangent is defined, again, similarly to sine, negative pi over 2 to pi over 2. So tangent of an angle is equal to a value a, then the inverse tangent of that value is equal to the angle. And again, just like the other ones, we have this arctan is another way of writing it. The domain is a little different, because if you remember, for tangent, the range could go from negative infinity to positive infinity. So here the domain can go all the way out to negative infinity and up to positive infinity. And the range floats between the two values, negative pi over 2 and pi over 2. So pretty much we're going to be using the unit circle to figure out some of these values. So we need to give our answer in radians. Now I included this after the unit circle because this is positive pi over 2, and down here is negative pi over 2. Alright, so what we need to look for is, where is the sine equal to square root of 2 over 2? And remember, this y coordinate is the sine value, so this is what I'm looking for. And that ends up being the angle pi over 4. Alright, so again, the inverse sine of that square root of 2 over 2 is just pi over 4. If we look at for -1/2, it's down here. Now you might be tempted to write 11 pi over 6. However, that wouldn't be in our between negative pi over 2 and pi over 2. So I need to actually just do this as negative pi over 6. All right. How do I get that? You could take 2 pi away from 11 pi over 6. And that gives you that negative pi over 6. Or you could just be like, all right, if that's pi over 6 up, that's pi over 6 down, so it's negative. Either way works for me. When we're looking for cosine values, the inverse cosine we're going to look at from 0 to pi. So we're just looking at the top half of the unit circle here. And then the cosine is the first one. So for cosine inverse of 1/2, I need to be right here. So that's the cosine. And that's at pi over 3. Negative square root of 2 over 2 is out here. And again, this value is actually between 0 and pi, so I can actually just write down 3 pi over 4. Tangent works very similarly to sine. I need to be between negative pi over 2 and pi over 2, and this right half of the unit circle is that for me. So what you need to realize is that this is 1. That means sine of the angle over the cosine of the angle equals 1. So I need to look for a spot where they match. In this case, they match here at square root of 2 over 2, square root of 2 over 2. So that value will be pi over 4. And here, with the negative square root of 3 on part B, I need values that will give me a negative. So that means I need to be down at the bottom of my unit circle because then my sine value is negative there. And I need something to get a square root of 3 out of that. And if I look down here, the negative square root of 3 over 2 divided by 1/2 is equal to negative square root of 3. So that means my value would go with that 5 pi over 3. However, again, I need to go away from the 0 backwards to that. So I've got to take it away. And in this case, it ends up being negative pi over 3. All right, if you want, you can see that's 60 degrees away. That's 60 degrees away, so that's negative pi over 3. You could do 5 pi over 3 minus 2 pi. And if you do that, you get 6 pi over 3. 5 minus 6 is negative 1. All right. And this is something you did in geometry, finding an angle in degrees. So again, you look at it, you decide, okay, I've got my opposite side over here, and I've got my hypotenuse. That means the sine of theta is 7 over 10, and theta is equal to the inverse sine of 7 over 10. Most calculators will have an inverse sine function. You want to make sure when it says in degrees, you do it with degrees. So if you're using Desmos, you want to make sure you have degrees. So what I can do, I'll show you how to do that on Desmos real quick. Hit the wrong button there. Alright, so in Desmos you can do it a couple ways. Number 1, you can go to functions. Under trig inverse, you could do arc sine and then do 7 divided by 10. Now, you got to make sure you're in degree mode though. Or you could also type in sine and then do the inverse by doing -1 and then do 7 divided by 10. And it'll give you the same answer. So either one works. Alright. Now, this is more stuff that you'll need your unit circle for. Alright. Pretty much what we need to do is find the value of the inside part first. And then we can go back to the outside part. So if we go to the inside part, this cosine of pi over 4, we can just change that to be square root of 2 over 2 from our unit circle. And then the inverse sine of that gives us back that angle pi over 4. Now it doesn't always work that way. In this case it does, because those two have the same value. So you look at the inside, find its value from the unit circle, and then you evaluate the inverse sine again using the unit circle. Alright, and this one, we need to use this to say this is our angle theta. Alright, so if I'm doing that, that means I've got a right triangle with theta. 3 is my opposite side, 7 is my hypotenuse. That means I need to find this third side. So I'll call it b here. And we just need to do Pythagorean theorem. So 3 squared plus b squared equals 7 squared. So that means b squared is equal to 49 minus 9. And b ends up being the square root of 40. And if we break that up, we get 2 square root of 10. Now, why do I want to do that? Well, I want to find the cosine of this angle. So the cosine of that angle, theta, is just the adjacent side over the hypotenuse. And I'm finished. So that's what this whole thing equals. 2 square root of 10 over 7. Alright, same kind of idea here. So we want to find a simplified expression for this sine of the inverse cosine of x over 5. Now, so we're going to start with this being theta. Because if I do the inverse cosine of an expression, that gives me the angle. So if I draw a right triangle, here's theta. That means x is my adjacent side, 5 is my hypotenuse. I need to find my third side using Pythagorean theorem. So I'm going to do x squared plus b squared equals 5 squared. And we're going to solve this for b squared. So b squared equals 25 minus x. B is equal to the square root of 25 minus x. Oh, that should be squared. Alright, so that means over here I've got the square root of 25 minus x squared. And now I need to do the sine of that angle. So the sine of that angle is equal to the opposite side over the hypotenuse. And that's my final answer. So again, as always, just ask questions if you need help. And that's all for now.